Hey everybody, it's Miss Berry. We're going to start section 1.4 in this video. And then this will be a two-part video because this section is not long, but the problems can sometimes take, a considerable amount of time. So I'm going to split it into two videos. This section is 1.4. It's called Rational Expressions. Rational expressions is just a fancy name for fractions. So rational expressions just means fractions. And specifically, these are going to be fractions with variables in the denominator. So you're going to have a variable in the denominator. All right, so the way to remember this is it has this root word here, ratio. So a ratio means a fraction, so maybe that'll help you remember that rational expressions are fractions. And you may remember back from when you learn about the different types of numbers that rational numbers are fractions. So rational numbers are numbers that can be written as fractions. All right, so here we have the definition of a rational expression. You don't need to write this down. You don't need to have it memorized, but there is one important part of this definition that I wanted to point out to you. So it says, I'm just starting here, a rational expression is an expression that can be written as a ratio of two polynomials, p over q. Okay, and here's the important part. Such a fraction is undefined for any values of the variables for which the denominator is equal to 0. Okay. So fractions are undefined. Fractions are undefined for any values of the variable that make the denominator equal 0. All right, and then the last sentence here, it says, a given rational expression is called simplified or reduced whenever the numerator and the denominator have no common factors other than 1 and -1. So once you have simplified, maybe you have factored the top and the bottom and you've canceled out any common factors, then you can call your rational expression simplified. But really, this is the most important part here that I wanted you to make sure that you understand what the word undefined means in the context of fractions. So you'll be asked to find, the values for which the rational expression is undefined. So make sure that you remember that means you're finding where the denominator is equal to 0, because we're not allowed to divide by 0. Right, so the whole reason that this exists is because we cannot divide by 0. Okay, so talking a little bit more about simplifying, the most important part up here is what I have highlighted. It says, to simplify rational expressions, we just factor the polynomials that are in the numerator and denominator completely and then cancel any common factors. All right, and then it also says here, it's important to remember that the simplified rational expression may be defined for values of the variable that the original unsimplified expression is not, and the two versions are only equal where they are both defined. All right, so that means that, once you simplify something, you may have canceled out some things that would make the denominator 0. All right, so you always want to start with that unsimplified rational expression and determine where it's undefined at. All right, so always start with the unsimplified rational expression when you're figuring out where that rational expression is undefined. All right, so here we have problem number 1. You may want to take a second, pause the video to write this down. It says, simplify the following rational expression and indicate values of the variable that must be excluded. So that means values of the variable that are going to make that denominator 0. All right, so let's go ahead and simplify this, and then we will take care of the last part. All right, so we have 2x divided by 9x squared minus 7x. All right, so right off the bat, I'm noticing that we have an x in the top. We have x in both of the terms in the denominator. So looks like we should factor out an x out of the denominator. All right, so we'll just leave the top alone for right now. Factor out an x down here. That means pull out an x. All right, so if you take out an x, there's going to be 9x left over minus. If you take out an x here, there's just a 7 left over. All right, now we can cancel out the common terms. So let me change the color. Cancel out our x's. So we have left 2 over 9x minus 7. Now you want to check and make sure there's no more common factors that can be factored out up here. It's just a 2, nothing to worry about here. 9 and 7 have no factors in common, so we know that this is now simplified. All right, but now we got to take care of the last part of the question. It says indicate values of the variable that must be excluded. All right, remember, like I just said, you always want to start off with the unsimplified denominator when you are determining where something is undefined. So let's go down here, start with that unsimplified denominator. All right, so we have 9x squared minus 7x equals 0. Go ahead and factor out an x. All right, so 9x, oops, not a square, just a 9x now if we pull out an x. All right, so you pull out an x, we have 9x minus 7 left inside. Right now you're just going to set both parts equal to 0. So x equals 0, that's one spot where it's undefined. All right, and then 9x minus 7 equals 0. Move the 7 over. Divide by 9. And there's our second spot where it's undefined. All right, so values of the variable that must be excluded. We'll just write a little sentence here. The values x equals 0, comma, 7 over 9 must be, sorry for the sloppy handwriting, must be excluded. Okay. All right, so we have to exclude those values because, remember, do y'all remember why we have to exclude them? We have to exclude them because if we plug those numbers in, they make the denominator 0, which would make us be dividing by 0, which we're not allowed to do. So we exclude these values here because we are not allowed to divide by 0. And if you plugged in either one of these numbers, it would make the denominator 0. Okay. All right. So just a word of caution here. This is a super common mistake. It says, remember that only common factors can be canceled. A common error is to think that common terms from the numerator and denominator can be canceled. For instance, if you have the statement something like x plus 4 over x squared, sometimes people will think, oh, okay, well, there's an x in the top and an x in the bottom, so I can just cancel one of each. You're not allowed to do that. In order for you to cancel the x's like that, you would have to have an x in each term in the numerator. Then you would have to factor out that x. Whoops. Let me just write that again. You would have to have an x in each term in the numerator. You would factor out the x. That would leave you just with a 1 here. 1 plus 4. And then you could cancel the x's. But you're not allowed to cancel when you just have, you know, an x in the top and an x in the bottom. You got to have an x in every single term that's in the numerator. All right, so let's look at another example. We're going to talk about here combining rational expressions. So of course there are our 4 basic operations. So you can add, subtract, multiply, and divide fractions or rational expressions. Typically the easier operations are multiplication and division. Addition and subtraction are considered more difficult because you have to find a least common denominator of your 2 fractions first. All right, so let's read this. It says, no matter which operation is being considered, operation referring to addition, multiplication, subtraction, division. I said that in a weird order. But anyway, no matter which operation is being considered, it's generally best to factor all the numerators and denominators before combining rational expressions. So what it's saying is that in general, you can start by factoring all of your numerators and denominators. This is a good first step because that's the first step in finding the least common denominator of two fractions. And the common denominator is essential before you add or subtract two fractions. Factoring first is an efficient way to identify any common factors that can be canceled if you are doing multiplication or division. Okay, so this is the 4 steps for adding or subtracting fractions. All right, so step 1, if you're adding and subtracting fractions, you factor all the numerators and denominators if you can. Sometimes you'll get lucky and you'll get a really simple numerator or denominator and you won't have to factor. So once you've got everything factored, you can find the least common denominator. Then you make sure each fraction has, or excuse me, make each fraction have the LCD. This is not like a formal way of saying that. That's just the way that I'm describing it here. It's sort of an informal way of saying, you know, build each fraction up so that it has the least common denominator. And then once each fraction has the least common denominator, you just add or subtract the numerators, and then your denominator is going to stay the same. All right, so this is your 4 steps for adding or subtracting fractions. All right, so this is our, I think I forgot to put the number here. So this is number 2, sorry. All right, so this is going to be our last example that we go through in this video, and then the rest of this section will be in the part 2 of the video. So this one says, add or subtract the following rational expressions as indicated and simplify your answer. This is a great question, great test question. You know, I might do something similar to this and then just change the numbers. I really prefer to use the variable x, but your textbook will use different variables. Here they're using y. So we have y plus 2 over y minus 5 minus y minus 4 over y plus 5. All right, so remember our 4 steps. Your first step was to factor all your numerators and denominators if possible. So let's just take a look at our numerators and denominators. Here we have y plus 2, that can't be factored. Y minus 5, that can't be factored. And then same over here, neither one of these, this numerator or this denominator, can be factored. So that's good. Let's look at our next step. Our next step is to find the least common denominator. All right, so I like to go over here off to the side kind of and just write the LCD. That way, like if you get distracted in the middle of the problem and you have to get up and do something else, you can always look back and see, oh, okay, yeah, I remember now. That was my least common denominator. That's what I was going for here. When you have 2 denominators that can't be factored, it is super easy to find the LCD. All right, so let me say that again. When you have 2 denominators, or when you're working with all of your denominators here and they can't be factored, that makes it really easy to find the LCD. All you have to do is just take each denominator and write it individually. So it's just the product of your 2 denominators. So y minus 5 times y plus 5. Super easy to find the LCD in that case. All right, so then remember our next step. We're done there with step 2. We found the LCD. All right, so remember our next step was to make each fraction have the LCD. All right, so you look at your first fraction, you say, okay, well, I've got y minus 5. I'm missing y plus 5. All right, so I'm going to multiply by y plus 5 down here so that I have the LCD now. But if I multiply something to the denominator, I also need to multiply it to the numerator so that I don't change the problem. All right, we'll go ahead and write out what we're going to multiply by here. We have y plus 5, so we're missing the y minus 5, so go ahead and add that in here. Multiply by y minus 5 in the bottom and in the top. Perfect. Okay. So remember, now we have the LCD here. We got y plus 5, y minus 5, y plus 5, y minus 5. All right, so remember the next step. It said once each fraction has the LCD, just add or subtract the numerators. Denominators stay the same. All right, so let's write this out. So we have y plus 5 times y plus 2 minus y minus 4 times y minus 5. It looks worse before it looks better. Actually, it may not look better at all by the time we finish. All right, so y plus 5, y minus 5. Remember, add or subtract the numerator, denominator stays the same. All right, so we need to multiply these out. Ugh, what a mess. Okay, so remember the FOIL method of multiplying binomials. First, outer, inner, last. All right, so y times y, that's the first. Y times y is y squared. Y times 2 is 2y, so positive 2y. Positive 5 times y is positive 5y. Positive 5 times positive 2 is a positive 10. Minus, now you got to be careful here because I got to keep that whole second part here in parentheses because I'm going to have to distribute that negative. All right, so I got y times y is y squared. Y times negative 5 is negative 5y. Negative 4 times y is negative 4y. Negative 4 times negative 5 is positive 20. All right, keep that denominator the same. You don't have to multiply it out. Ooh, all right. Go ahead and combine like terms. We got y squared plus 7y. Now, you don't have to write out every step. If you can do some of this in your head, that's great. That'll save you some writing. So we got y squared minus 5y minus 4y, so that's minus 9y plus 20 all over my LCD, y plus 5, y minus 5. Like I said, just leave that alone for now. I don't know why I wrote 2 parentheses there. Let's try that again. Okay. All right, now go ahead and distribute this negative here. So I'm just going to write a little note in here. Distribute. See if I can fit it in here. Distribute the negative. Very important, super common mistake is to forget to distribute the negative. All right, so that means we're going to distribute the negative to each piece. Oh, overshot it a little bit there. There we go. Keep losing my pen. There we go. All right, so first part's going to stay the same. Y squared plus 7y plus 10. Distribute the negative, so that's minus y squared minus negative 9y, so that's going to be plus 9y, minus positive 20, so minus 20. Whew. Y plus 5, y minus 5. Okay, whew, we're almost done. All right, so let's combine like terms. Whoops, went too far. Click the wrong button. All right, so let's cancel common term, or see, we got a positive y squared and a negative y squared. All right, then we got 7y plus 9y, so that's going to be 16y. All right, so 16y plus 10 minus 20, so that's going to be a minus 10, right? 10 minus 20. All right, and we're almost done. The last thing that I see that you could do here is pull out a common factor out of the top. 16 and 10 have a common factor of 2. So you could pull a 2 out of the top. So that'd be 8y minus 5. It doesn't really help us cancel anything, but it is now simplified completely. And that's it. I know that was a lot of work, but it's really, nothing you haven't done before. It's just you have to be super careful not to make a mistake, and really take your time and think about at each step what you're doing. Okay, so that is going to be it for this video. We're going to go through the rest of the operations in part 2 of this video. But please feel free to let me know if you have any questions, and I'll talk to you guys soon.